Behavior-driven development is an outside-in style of development, starting with tests that specify the behavior of the application. The tests are known as specifications because they specify behavior, and they're written from the point of view of the end user. The scenarios are often specified using the given, when, then syntax, which is a nice neat way to divide tests logically into the context in which the test is being run, the action that occurs, and then a set of observations where we assert that the expected behavior is the actual behavior. In the JavaScript ecosystem, there is a tool called Jasmine for behavior-driven development. The syntax is reminiscent of a similar tool for Ruby called RSpec. The documentation for Jasmine and the download is online at pivotal.github.com/Jasmine. Here you'll find examples, documentation, and all of the download links. The BDD specifications are grouped into suites, and suites are declared using the describe function. Inside a suite, context can be established for all the specifications using the before each method. Each specification is then declared using the it method. The it method takes a string describing how the application should behave and a function. Inside the function, we perform some action and then assert the expected behavior. Let's have a look at an example Jasmine test project. This is going to look rather similar to the QUnit tests. Again, Jasmine tests are based around a HTML page. Also, like QUnit, there's some standard files we have to include, a CSS file, and in this case, a couple of JavaScript files. We then include the source files that we want to test, and we include the specifications. And finally, once all those scripts are loaded, there is a couple of JavaScript calls to start the testing process. In this example, the specifications are stored in a file called calculatorspec.js. As I mentioned, the specs are grouped into suites, and suites are declared with the describe function. So we have a suite called calculator. Within that suite, there's a variable, also called calculator, and there's a before each function, which initializes that calculator with a new calculator object. It's possible to nest suites. So here within the calculator suite, there's a new suite called when adding positive numbers. So that's going to group all of the specifications that have to do with the adding of positive numbers by a calculator. Before each of those specifications, two variables are initialized, first num and second num, and given positive integer values. And in this suite, we have just a single specification saying that the calculator should calculate the correct results when adding positive numbers. The calculator object is used to add the two numbers together, and the result is stored in a variable called result. We then use some of the assertions built into Jasmine to specify that we expect the result to equal 68. This file includes another suite of specifications, this time for adding positive and negative numbers. Again, the before each method is used to set up the context before running the specifications, and this time we're initializing three integers, two of which are positive and one of which is negative. There's then another specification saying that it should calculate the correct result. Again, calling the add method on the calculator object, this time adding together three numbers and expecting that the result will be equal to 700. If we now open the file specrunner.html in a browser, we get a rather similar output to QUnit, except that it's telling me that one of my specs is failing. When adding positive and negative numbers, it should calculate the correct result. I'm expecting a result of 701, but the actual result is 700. If I go back to my specifications and take a look at the context that I've set up, 14 plus 54 plus negative 769, I can see that it's actually my specification that's incorrect, because when those three numbers are added together, the result is in fact negative 701. So I correct that error, Swap back to the web page, run it again, and this time we see 2 successful specifications.